One important feature of the strain rate tensor Sij is that it is 0 for rigid body rotation and translation. That is to say, Sij is only non-zero if a fluid element is actually deformed. One result of this property is that Sij is invariant under Gaussian transformations. And that means that certain properties of the tensor don't change under rotation or translation. And for a first order tensor, an invariant for a first order tensor, i.e. a vector, is its magnitude. So if you change your frame of reference, or if you rotate your vector, the magnitude will never change. For second order tensors, for a second order tensor, there are 3 invariants. So for the first order tensor there's only 1 invariant. For the second order there's 3, and I'll list all 3 here, but I'll focus only really on the first one. And the first one we've encountered before, invariant 1, is the trace of our strain rate tensor, which is written as SII, which means it's just the sum of the diagonal elements. So that sum here never changes under rotation or translation. The other 2 are a little more complicated. One is a half the trace of S squared, which is a half Sij Sji, and the third one is a third of the trace of S cubed, which is a third Sik Skj Sji. I'm only listing these really for completeness right now. The important one is the first one, and that one has a very straightforward physical interpretation, namely it's the volumetric strain rate. If you consider a small fluid volume delta V, which is just delta x1 times delta x2 times delta x3, you can show that this volume changes over time. Yeah, so if you look at the material derivative of this, and particularly in the case where it's per unit volume, you find that this is just given as du1 dx1 plus du2 dx2 plus du3 dx3, which is just SII. So this is the rate of volume change per unit volume. And that will always be the same, independent of your coordinate system. Or even if you have a rotating frame of reference. Independent of coordinate system. And to show this, you can do, it's actually given as an exercise in the book. So look at exercise 320 in Kundu.